On the 28th of April, 1988, the passengers on Aloha Airlines Flight 243 were finishing their drinks somewhere over the ocean between the Hawaiian Islands. A moment later, the roof of the cabin above their heads was simply gone. At 24,000 feet, an ordinary Boeing 737 had ripped away about 18 feet of its own fuselage, and along with the ceiling, a flight attendant was swept out into the open sky. And yet nearly all 95 people on board lived through it. How does a plane with its cabin torn open like a convertible even manage to land? And what tore this solid-looking machine apart with no explosion at all? It came down to metal that had simply been growing tired for far too long, and to a crew left with the job of landing whatever was still holding together. In Hawaii, hopping between the islands is as routine as catching a bus. That day, Flight 243 was just supposed to shuttle people from the Big Island to the state capital, a short jump from Hilo to Honolulu, one of dozens the airline ran every single day. The aircraft for the job was a Boeing 737, the -297 model, tail number November 73711, and it had a name of its own, Queen Liliuokalani. It had rolled off the line in 1969, which made it 19 years old by the spring of '88. Over those years, it hadn't actually flown all that much, around 35,500 hours. But there's a second yardstick for how much an airframe can take, and it matters far more: the number of takeoff and landing cycles. Every cycle means the fuselage swelling and shrinking under pressure, like a balloon being blown up and let down again. The Queen Liliuokalani had been through 89,680 of them. That was the second highest figure of any Boeing 737 in the world. The airframe's economic design life was rated at roughly 75,000 cycles, and this machine had blown past that mark long ago. It was one of the oldest, most worn-out 737s flying anywhere on the planet. The reason for that number is simple. Aloha ferries people between the Hawaiian Islands, and those flights last 20 to 40 minutes. In a single day, one aircraft takes off and lands over and over, and every takeoff adds another load cycle to the metal. Add the climate, damp, salty sea air that quietly eats away at aluminum with corrosion. From the outside, it looked like a sound, well-kept airliner. But on this particular flight, a routine island hop was about to become one of the most studied cases in the history of civil aviation. And it would force the whole industry to answer an uncomfortable question: could the disaster have been seen coming? One person that day actually did notice a warning sign. As she boarded, a passenger named Gail Yamamoto spotted a crack in the metal skin near the entry door. She said nothing. She figured the airline surely knew the state of its own planes better than some random passenger. So she kept it to herself, and everyone settled calmly into their seats. Later, that moment would become one of the symbols of the disaster, a red flag visible to the naked eye, right there at the boarding stairs that never reached anyone who could have pulled the plane from service. That crack didn't come out of nowhere. It was all down to how Aloha operated. For a passenger, lots of short flights are a convenience. For the airframe, they mean constant work under strain, and thousands of those cycles build up invisible wear in the metal over the years. The flight crew of 243 was experienced. Captain Robert Schornstheimer had around 8,500 hours in the air, a lot of them on these short island runs. First Officer Madeline "Mimi" Tompkins had about 8,000 hours, and she was training up to make captain. Working the cabin were the flight attendants, Clarabelle C.B. Lansing with 37 years on the job, along with Jane Sato Tomita and Michelle Honda. At 1:25 in the afternoon local time, the Queen Liliuokalani lifted off the runway at Hilo. There were 95 people aboard, 89 passengers and 6 crew. Ahead of them, the usual 40-minute trip. Neither the pilots nor the controllers had any idea that along one of the seams in the skin, a whole row of fatigue cracks had already lined up. The takeoff was routine. The plane climbed and leveled off at around 24,000 feet. First Officer Tompkins was flying. Captain Schornstheimer was watching the instruments. The weather was calm, the aircraft responsive. An ordinary flight, the kind this crew had done hundreds of times. In the cabin, the little ritual of a short flight was getting underway. the drink service. The flight attendants rolled the cart down the aisle, the passengers were relaxed, Honolulu practically within reach. Clarabelle Lansing was working the front of the cabin, standing by the fifth row of seats with her back to the nose of the plane. At cruising altitude, the load on the airframe is the heaviest it will be all flight. The higher the plane, the bigger the gap between the pressure inside the sealed cabin and the thin air outside. That thin aluminum skin was stretched to its limit. Metal weakened by years of cycles and corrosion was holding that load right on the edge. In the cabin, still nothing gave the danger away, but along one of the seams in the skin, the tiny cracks around the rivet holes, the ones that had been piling up over thousands of flights, were about to link into one continuous line. The passengers were looking out at the ocean, noticing nothing. It was down to seconds now. At 1:46, there was a deafening bang and then a monstrous roar. This was an explosive decompression. In an instant, a huge section of the upper skin tore away from the fuselage, about 18 feet of the cabin roof ahead of the wing. Where a second ago there had been a ceiling, now there was open sky. The breach ran from just behind the cockpit all the way to the leading edge of the wing. The cabin floor bulged upward as air from the cargo hold pushed up from below. The cockpit door was torn off its hinges. In a heartbeat, the crew was exposed to the cabin, and the cabin was exposed to the stratosphere. At that moment, flight attendant Clarabelle Lansing was standing at the fifth row, right under the section that tore away. The rush of air carried her out of the plane. She became the only fatality of the disaster. She was never found. She was 58 years old, and she had given 37 of those years to working in the sky. A freezing hurricane-force wind poured into the cabin. At 24,000 feet, the air is thin and bitterly cold, and there is barely anything to breathe. Pieces of the skin battered the wing and the engines. Passengers were pinned into their seats, belongings and papers flying through the cabin. In a matter of seconds, a peaceful flight had turned into an open platform, wide open to the wind, hurtling through the sky at airliner speed. Whether the plane would hold together as one piece or whether it would keep breaking apart, in those seconds nobody knew. Up front, the pilots at first couldn't work out what had happened. Captain Schornstheimer felt a sharp jolt and heard a roar behind him. He turned around and saw where the front cabin bulkhead used to be, a gaping hole in open sky. The crew's first guess was an explosion, maybe a bomb. The real scale of what they had lost hadn't sunk in yet. The cockpit was now held on by nothing but the floor beams. The pilot seriously feared it might snap off from the rest of the body, but there was no time for fear. Schornstheimer took control from Tompkins and started an emergency descent. The captain had 8 years behind him as a military flight instructor, and even a stint as an air traffic controller, and over his years on the island routes he had flown something like 15,000 landings. Now all of that experience was what counted. Schornstheimer moved fast, not wasting a single second on doubt. The task was brutally clear: get down as fast as possible from the altitude where there was nothing to breathe, and take the pressure difference off that stretched-out fuselage. The nose dropped, and the airliner went down at about 4,000 feet per minute, building up to roughly 290 knots. That was near the limit. Descending a damaged plane any faster would have been dangerous. The roar of the oncoming air in the open cockpit was so loud the pilots couldn't hear each other, or even their own voices. So they switched to hand signals, pointing out the heading, the descent, what to do next. Two people flying a crippled airliner, trading gestures like a silent movie. Schornstheimer would say later that he was focused on one thing: getting the machine down to the ground, and he wouldn't let himself think about what would happen if he didn't. Back in the torn-open cabin, there was a fight of its own going on. Every movement here was a struggle. Flight attendant Michelle Hondo was thrown to the floor in the very first seconds, and the passengers themselves held on to her, grabbing her clothing so she wouldn't be dragged toward the breach. People clutched their armrests and each other, ducking down under the wind. Some were held up almost literally in midair by their seatbelts. Jane Sato Tomita, the third flight attendant, lay unconscious in the front of the cabin with head injuries. She had been struck by debris, The oxygen masks, the ones that are supposed to save you in a situation like this, were useless. The oxygen lines had been torn away along with the ripped-off ceiling. Honda kept working anyway. She crawled down the aisle against the wind, clinging to the seats, helping people get their life vests out and calming them down. The passengers had no idea what was happening in the cockpit, whether the pilots could even hear them, whether anyone was still alive up where the ceiling used to be. Eric Becklin, an astronomer sitting in a back row, recalled later that in the first instant he was sure this was the end. To keep the panic at bay, he forced himself to read the instructions on the life vest. As the airliner shed altitude fast, First Officer Tompkins did what was still possible. She got on the radio. Cutting through the static and the roar, she called the control facility on the island of Maui. Broken fragments went out over the air. "We have a decompression, we've lost pressurization, declaring an emergency." She kept her voice steady, even with a wide-open cabin at her back. A little later, Tompkins spelled out the picture as the crew saw it. "Looks like we've lost a door, we have a hole in the left side." From the cockpit, they couldn't see the whole breach, so what went out on the air was far more modest than the reality. The crew warned the controllers they couldn't reach their flight attendants and asked them to have help ready for the passengers on the ground. The captain asked ahead of time for emergency vehicles and stairs to be brought to the runway. He knew that once they stopped, the plane would have to be evacuated in a hurry. The nearest runway they could realistically reach was Kahului Airport, on that same island of Maui. That's where Schornstheimer aimed the plane, but the path wasn't simple. The Haleakala volcano rises more than 10,000 feet over the island, and it had to be flown around, not clambered over in a damaged aircraft. The crew descended and lined up on the approach to the island. From the outside, it looked like the worst was behind them. Land was close, the runway ahead. But that was deceptive. Some of the systems had been damaged along with the skin, and the failures would reveal themselves one by one, right there on the approach, when there was almost no room left for a mistake. The first to make itself known was the left engine. On the approach, it lost thrust. As it turned out later, the strain on the deformed body had snapped a corroded engine control cable. Now Schornstheimer had to land the airliner on effectively one working engine. A plane like that couldn't go around for another try. The approach became the one and only shot with no way back. Next, the flaps. Those panels on the wing are extended so the plane can fly slower and touch down more gently, but extending them made the damaged aircraft much harder to control. The captain settled on a compromise. He set the flaps to just 5 degrees and came in at a higher speed. The price for staying stable was around 170 knots on the glide path, noticeably faster than a normal landing speed. Then the landing gear. The struts came down, but the indicator in the cockpit wouldn't confirm that the nose gear had locked into place. The pilots didn't know whether it would take the impact with the runway or fold underneath them. Tompkins put it plainly over the air, "We have no nose gear, we're landing without it." It was a decision made out of desperation. There was no choice anyway. And on top of all of that, the controls themselves felt heavy, like flying by hand. The usual help from the automatics had weakened, and every movement of the yoke took muscle. The crew was wrestling together a machine that had lost an engine, had limited flaps, questionable landing gear, and part of its fuselage gone. Any one of these failures on its own is already a serious emergency. Here they had all come at once, and ahead of them was only a single attempt to land. 1:58. About 13 minutes after the decompression, Flight 243 touched down on runway 2 at Kahului Airport. To the captain, it felt like the plane was springing like the end of a diving board. Schornstheimer genuinely feared it would break in half during the rollout, but the plane held. The nose gear, the one nobody had been sure about, held up under the touchdown. The airliner rolled down the runway, bled off its speed, and came to a stop. The mangled machine was on the ground, in one piece. Aloha's ground manager, Larry Miller, had watched the approach from the ramp and was convinced the plane was going to crash. The moment it stopped, the first thing he did was start counting people and getting help moving. On Maui, there are only a handful of ambulances, nowhere near enough for all the injured. They started carrying the wounded out in the minivans of tour companies that happened to be nearby. The toll of those 13 minutes, 65 people injured, 8 of them seriously. Of the 95 who had gone up into the air at Hilo, 1 didn't come home, Clarabelle, Lansing. 94 survived. The scale of what had happened didn't reach people right away. The ground manager would later compare that landing to the famous ditching on the Hudson and say the Flight 243 case was every bit as unbelievable, if not more so. Some of the surviving passengers were back on a plane the very next day to keep the fear from taking root. Later, this aircraft would be called one of the most badly damaged airliners ever to land under its own power. Miller, stepping inside, said it was like walking on a sponge with a cardboard floor, and that the plane was held together by nothing but the floor beams and someone up above. The landing had worked, but now the second half of the story was beginning, figuring out why any of this had happened at all. And there, the simple answers ran out. The first thing that comes to mind for anyone who sees a gaping hole where the ceiling should be is that something exploded on board, maybe a bomb. And that's exactly the theory the investigators from the National Transportation Safety Board, the NTSB, worked through first. The logic makes sense. A fuselage section torn away that cleanly looks like the result of one powerful, instantaneous failure. The specialists searched for traces of an explosive, the telltale damage, soot, chemical residue. If it was an act of terrorism, those would have survived, but they found no signs of a blast. The picture didn't add up to sabotage. No explosive, no evidence any had been used. What made it harder was that the key piece of evidence, that very section of skin that tore away, had fallen into the ocean. 3 days of Coast Guard searching turned up nothing. Not a scrap of skin that could have told them where the failure began, and no trace of Clarabelle, Lansing either. So the attention shifted to the metal itself, to what was left. The investigators studied the riveted seams, the longitudinal joints of the skin panels, the state of the airframe along the whole length of the body. And here they hit their first serious discovery. A fragment lodged in the right wing during the breakup carried at least 5 fatigue cracks. They weren't fresh, they were old, and most importantly, they could have been found by instrument inspection long before that fatal flight. The explosion theory was out. Now the investigation had a far more uncomfortable job: to understand how ordinary metal fatigue rips away a whole section of fuselage all at once. The answer lies in how the Boeing 737 fuselage is put together. The body is made of thin aluminum sheets, about 1 millimeter thick, laid overlapping. The places where the sheets overlap are called longitudinal lap joints. They were held together 2 ways at once, with rows of rivets and with an adhesive bond, using a cold bonding process. The glue was meant to spread the load evenly and to make assembly cheaper, but it had a weak spot. In the damp, salty climate, moisture worked its way into the joint. The adhesive lost its grip and peeled away, and engineers call this disbonding. And wherever the glue let go, the rivets alone had to take the entire pressure load. This is where the failure begins. At the edges of the rivet holes, the metal was working at its limit, and microcracks were forming in it. The rivets sat in countersunk holes with a sharp inner edge, a kind of knife that let the cracks spread especially easily. With every new pressurization cycle, they grew. One longitudinal joint turned out to be key. In the documents, it's marked as joint S10L. Along it, the cracks multiplied and gradually lined up into one common line. The designers had anticipated fatigue and built in a safeguard. The idea was that when a crack appeared, the fuselage would vent the pressure neatly. A small flap of skin would open, special tear straps would stop the rip, and the decompression would come out controlled. But on the Queen Liliuokalani, so many cracks had built up that they joined almost simultaneously over a great length. The tear straps couldn't cope with a front that wide, and instead of a small flap, 18 feet of roof tore away all at once. That left one last question. Why had all these cracks stayed invisible for years? Because nobody was really looking for them. As they picked apart the work of Aloha's maintenance department, the NTSB investigators uncovered one problem after another. On this particular aircraft, the required eddy current inspection had never been carried out, the method that finds hidden cracks in metal with instruments without removing the skin. That was exactly what could have revealed those very rows of cracks at the rivets. Next, the way the heavy maintenance was organized. The deepest inspection, the so-called D-check, the airline broke into 8 separate pieces and ran overnight between flights. In a rush, in poor lighting, spotting a fine crack is next to impossible, and the damage they did find was often just covered over with patches without dealing with the cause. There was a systemic problem, too. Aloha didn't have engineers on staff who could properly read the service bulletins and safety directives the manufacturers sent out. Most of the inspectors had less than 2 hours of relevant training. They physically couldn't judge what they were looking at. The supplementary inspection program in force didn't even require targeted inspection of the skin at all. The assumption was that a failure wouldn't have time to reach a dangerous state and would become visible to the naked eye. That assumption turned out to be fatal, and the bitterest part. Back in October of 1987, half a year before the disaster, specialists from Boeing had visited Aloha and warned them straight out there were too many patches and too much corrosion on the planes, and the aircraft needed to be pulled for serious long-term repairs with parts replaced. The recommendation wasn't acted on. The plane kept carrying passengers. All the signals were there. They just never got put together into one picture. But the airline wasn't the only one in this story who looked away. The official NTSB conclusion is worded soberly, but that whole chain stands behind the phrasing. The primary cause was named as the failure of Aloha's maintenance program. It hadn't detected the disbonding and the fatigue damage that led to the breakup of the S10L joint and the loss of the fuselage section. But the investigators didn't stop at one airline. Among the contributing factors, they cited weak oversight by Aloha's management of the quality of the repair work. Then the lapse of the government regulator. At the Federal Aviation Administration, the FAA, one specialist inspector was effectively responsible for a whole group of Pacific carriers, with no way to keep up with all of them. It was the FAA that hadn't required timely mandatory inspection of the problem joints, even though there were grounds for it. The manufacturer had a share too. The cold bonding technology for the joints turned out to be vulnerable, and Boeing, knowing about the defects on the early aircraft, hadn't taken decisive action. It hadn't required the problem joints to be replaced on the planes already flying. What emerges is the pattern aviation calls the Swiss cheese. In every layer of defense, at the carrier, at the regulator, at the manufacturer, there were holes of its own. On its own, each one might have been covered by the neighboring layers, but that day the holes lined up and the chain ran all the way through. And underneath all of it, one more fact. The plane was being used twice as intensively as the calculations had assumed. The short sea hops piled up cycles at double the speed, and the aging of the airframe outran anyone's expectations. In the fierce competition on the island routes, the airlines tried to keep their planes in the air as long as possible, and heavy repairs with downtime were bad business for a carrier. Economics was working against safety. After the 28th of April, the industry had to admit it. Flight 243 became the push behind a national program to monitor aging aircraft, the Aging Aircraft Program. The whole attitude toward older planes changed at the route. As early as June of 1988, an industry conference on old aircraft locked in a new principle. You can't just watch wear and patch it. Worn parts have to be replaced on a schedule without waiting for them to fail. The NTSB issued something like 20-odd recommendations. Among them, mandatory certification of inspection specialists, structural fatigue testing with a large margin, and tying maintenance schedules not to the calendar but to the real number of cycles a given aircraft had flown. Inspections of other Boeing 737s right after the disaster turned up dozens of cracks at 15 operators around the world. The same trouble was hiding in a lot more than just Aloha's planes. 2 of Aloha's own aging aircraft of the same type were sent for scrap after the disaster as well. And on an industry scale, the new rules paid off. Airframe failures in flight on passenger airliners became a great rarity. The Queen Liliuokalani herself was beyond saving. The aircraft was declared unrepairable and taken apart right where it had landed at Kahului Airport. The people's fates played out in different ways. Captain Schornstheimer struggled for years with the aftermath of the stress he had been through and later stepped away from flying. He admitted that something like that never fully lets go. First Officer Mimi Tompkins went on to make captain and then helped build a psychological support program for pilots who had been through something similar. In memory of Clarabelle Lansing, a memorial garden was opened at Honolulu Airport in 1995, and the flight itself, the one that lost the roof over its passengers but kept almost all of them, has been studied in flight schools ever since. The lesson is simple and hard. Even a familiar plane that has flown thousands of times isn't forever, and in those minutes when everything fails at once, the only thing holding the machine up is the training of its crew.